Here we have another example where we've got a coefficient in front of our variable. So again, we've got the variable theta, and this time within our cosine function, there is a coefficient of 4 to that. So we're going to have to do the expanded domain thing again. So what we're going to do is we take our domain here and we times it all by 4 so that the thing in the middle will be something that we can do a substitution for. So if you think about it, minus pi and 2 times 4, you're going to get a bit of cancelling, and you're going to get minus 2 pi is less than or equal to 4 theta. It's less than or equal to 2 pi. And then we can just say, well, I'm going to let 4 theta equal, doesn't matter what the variable is that you're doing the substitution for. Let's do x this time. So now we can say, well, 4 cos of x is equal to 2. For this domain where, well, let's actually just rearrange it a bit. So divide both sides by 4, make it that nice thing that we like looking at. So it's what, 2 on 4, which is a half. For minus 2 pi is less than or equal to, we can replace this 4 theta with x. X is less than 2 pi. So now we know we're looking for values of cos of x that are equal to a half between minus 2 pi and 2 pi. So next we draw our unit circle, so to speak. I just draw the axes. I don't actually bother drawing the unit circle every time. And then I just kind of put in my angles. So if you think about it, if we're going to negative 2 pi, well, let's draw our CAST. So what? It's positive a half. So we got to be in either the fourth quadrant or the first quadrant, because that's where cosine's positive. So half, just quickly draw myself my rather shoddy drawing of this triangle. Pi on 3 here. So if you think about cos of pi on 3 adjacent over hypotenuse, it's going to be a half. So we're going to have some where there's pi on 3 here, some where there's pi on 3 here, so always with the x-axis here, and it's just going to be all the angles that end up like that between minus 2 pi and 2 pi. So let's think about it. Well, minus pi on 3, that'd do it. So x could be minus pi on 3. Then as we go around here, it'd be pi on 3 less than minus 2 pi. So that would be minus 5 pi on 3, I believe. If it takes you a bit longer to kind of work out what these are, that's okay. Maybe just pause the video and make sure that makes sense to you. So that's it. We're at minus 2 pi if we go all the way around there. There's no more that are going to satisfy that. We also have to get the positive ones though. So one that would work is positive pi on 3. And then the next one that would work would be all the way around at positive 5 pi on 3. So you might notice a bit of kind of symmetry here, perhaps unsurprisingly, when we're dealing with something like a circle. It loves symmetry. So here we are. They're actually not really written in order, are they? Because this is a smaller number than that. And we do like to write them in order from smallest to biggest, just makes it easier for your examiner. So I'm just going to fix it up on the next line because I'm going to want to do my substitution back to theta. So x is 4 theta, so I'm just going to write, well, 4 theta is minus 5 pi on 3, so that's the smallest one, minus pi on 3, pi on 3, 5 pi on 3. And then it's just a matter of dividing everything by 4. And if I think about it, if I divide by 4, so this should be getting smaller, right? You could do the fraction mucking around if you want on another thing, but I can kind of notice that this is going to be minus 5 pi on 3 times 4, i.e. 12. And minus pi on 12. And pi on 12. And 5 pi on 12. And those are going to be all of my possible solutions for this domain for that equation. And there you have it. So yeah, let's